start with the simple 3, 4, 5 right triangle to explain this problem. We've got a right triangle, ABO, where the coordinates of the vertex A are 0, 0, and the coordinates of B are 3, 4. So we've got a 3, 4. That means by the Pythagorean theorem, the length of the hypotenuse AB is 5. And we want to find a point along the line segment from A towards B that is 2/5 of the entire distance. I could make that any fraction I wanted to, but I chose 2/5. Makes the numbers a little bit easier to work with. So 2/5 of 5 of the entire distance means we want AP to be 2. 2/5 of 5. And because we have two right triangles here with a common acute angle, angle A, the triangle APQ, the little triangle right here, is similar to the big triangle ABO. And because similar triangles have corresponding sides that are in proportion, we can write these ratios as equal to each other. So for AP to AB, 2 is to 5, the small side, small hypotenuse is to the big hypotenuse, as AQ is to 3. That's this little leg is to the big leg, AO. And if I solve that for AQ, I get 2/5 times 3. I've got this circled right here because we're going to use this technique on the next page. If I take 2/5 of this horizontal distance, I will have the length of that leg right there. Okay. And if I do the same for 2/5 of 4, this leg, I'll get 8/5, and that's the length of this leg. And by the Pythagorean theorem, I've proven that that is satisfied. The question is, what are the coordinates of point P? Well, I have to add on this distance to the x coordinate of point A. So I'm going from A towards B. So that means the x coordinate of point P is larger than the x coordinate of point A. And similarly, add 8/5 to 0, and I get to here. But what about if B is to the left of A, like in this diagram? And what if the A is not at 0, 0? Well, the technique is the same. Here's still the same value of K. And the strategy is this: the x coordinate of point P, we start at A dot x, which is 2, and we add on the directed distance from A towards B, the horizontal component. And that distance right there, the directed distance, excuse me, is -1 minus 2. We actually treat it as a negative distance because we want to make the x coordinate of A smaller. So there's your formula right there. So the starting point x coordinate is 2, add on 2/5, that's the ratio, of the directed distance from A towards B in a horizontal direction, -1 minus 2. So the x coordinate of point P is 4/5. And similarly for the y coordinate of point P, it's the y coordinate of the starting point plus 2/5 times the directed distance from A to B in a vertical direction. That's the change from 9 to 5. Notice that if you change the orders here to A dot y minus B dot y, you'll be adding on a negative number. You'll be going in the wrong direction. So there's the y coordinate of point P. And these are the two formulas that you want to remember right there, where A is the starting point, B is the ending point. We're going from A towards B. There you go. Hope that helped. If you have any questions, post a comment.